So here we have a problem with this driver board where you can see I'm in single lamp and I'm only supposed to be lighting lamp 11, I guess. But all the lamps in the row are lighting along with that. And if I just advance to the next lamp, you can see what's going on. So anytime that a lamp is lit, all the lamps in that row are lit, no matter what column. And here's column 8. So it almost looks like we're in lamp row test, but we're not. We're in single lamp test. Let's go figure out what's going on here. One of the chips in the WPC lamp matrix is U18, an LS374, and it's a buffer chip, and whatever comes in on pin 4, for instance, should be copied out to pin 5 whenever the clock and the chip select signals pulse. And since I'm in lamp test, that should be happening all the time. And this chip drives the ULN 2803s, that drive the TIP 107s, that allow the lamp columns to drive. So let's just check a pin or two here. 4 goes into 5, 3 goes into 2. I've got my logic probe. 4 is pulsing, 5 is high. 3 is pulsing, 2 is high. Let me do that again. 3 is pulsing, 2 is high. So you can see that that integrated circuit is not following the logic that it should. So I'm going to replace that chip and I'll be right back. So I had cleanly removed the LS374, put a socket in and put a brand new 374 in. And we are back in lamp test. And you can see that everything's working as it should. Let me go back to single lamp test. And the only lamp on is the shoot again lamp, which is the first one, and the out lane. And I can go through these one at a time, and you can see they're working the way they should now. So let's do some other tests while we're here. This board, I'll describe it later on the bench, but it was subjected to high voltage, the MPU, the driver board, and the sound board. So let's test all of it out at one time here. I'll come back and do the switch tests. What was that one? It looked like the center jet is working here, so we need to get that taken care of. Okay. Let's do the GI. That's my GI tester, and I put some bulb condoms on there just so it wasn't so bright. Let's do all lamps. And that is working correctly. Let's do lamps and flashers. It's easy on whitewater to see the flashers operating here. And it looks like that top right flasher, or 2 top right flashers, are not working either. We'll have to get at those. So let me take, well, let's do sound test because the soundboard was impacted too. There we go. So here are some of the parts that came off the board. These are the boards. These are all the caps from the soundboard. There's the ASIC and the 6809 that I'll send back to the client. And I forgot to mention also that this PLCC chip carrier, which the ASIC sat in, had some corrosion in it. You can see it at the bottom of these pins over here. So that had to come out. That's just a blast desoldering an 84-pin PLCC carrier. We are nearing the home stretch on these MPU driver board and soundboard from this FishTales. And the last two things I want to do is switch matrix test. So I have my switch matrix tester connected to it. So that was all of column 1 and the rows that are used on FishTales. The two right rows are columns 7 and 8 are not used in FishTales, so we are seeing exactly what we should be seeing. Let's put it in the sound test, and I have the FishTale ROM in the soundboard now. One interesting thing I'll note is when I was testing with some FishTale, with some whitewater ROMs just a moment ago, you may have seen the screen say 100 million, which is the typical call out that everybody's used to on whitewater, but it called out 50 million. And the reason for that is the sound ROMs that I had in there are an older version than the latest ones. So I put the latest ones in there and it all worked correctly. So let's see what FishTales sounds like.
I tell you, it was this big. Biggest fish I'd ever seen. Whoa, you got one under, eh? Oh, yeah, that's a keeper. Get out of here. You've mastered deep sea fishing. Up to the top for double jackpot. Double jackpot. Super jackpot. It's a feeding frenzy. Whoa, you're not going to eat that, are you?
Wow, they packed a lot of sound into that single sound ROM. Kind of makes me want to go fishing now. So we're all set. Let me get these boards on the bench and explain everything that I did to them. All right, let's go over everything that I needed to do to repair this driver board, sound board, and MPU board. The problem statement is that the boards are from a FishTales. I figured out a way to connect the solenoid driver to the 5-volt logic power via wrong connectors. Now nothing works. Let's see. Driver board, sound board, Fliptronics board. I have to go find that Fliptronics board in there and repair that too. But so let's start with the driver board. When you subject 5-volt logic chips to higher voltage, they can withstand it for a little while, but not necessarily for a long time. And on this board, if you diode tested, positive lead of your meter and diode check here, negative here, it was a dead short. So something on this board was shorted. There is no good way to figure out what exactly that is. You have to resort to pulling chips in a somewhat methodical way until you find the ones that are shorted. So I started pulling here, no joy, here, no joy. Here, this one was shorted, but the short still existed on the board, so that meant another chip was shorted. When I pulled this one, it was shorted also, and the short on the board went away. Of course, in testing then, later on, we found out that this 374 in the lamp matrix was not operating properly either. Somebody had already replaced this chip. before, and they'd already recapped this board here. I'm going to replace this cap and this cap before this board leaves my shop too. I replaced the power out and power in headers. GI headers look good, so I didn't do anything to those. So this board is good to go as was shown in the test. Let me put this over the top of this just to avoid any unnecessary problems with shorting. The CPU board, unfortunately, it blew out the processor. The ROM was good. I installed NVRAM, but the RAM had failed. And the worst problem was that the ASIC blew up. Now, these ASICs used to be 25 bucks. Now they're, I think, $89. So that's going to be quite an investment for the client. I also replaced the input power filter cap and the power header. Somebody had already replaced U20 and did a crappy job at it, I'll just say. Now the soundboard had me a little worried when it played. It said 50 million when the screen said 100 million. But the components on the soundboard were good. I put a label on the FishTales ROM. I recapped it with 1, 2, 3, 4, 5, 6, 7 47 microfarad caps, a 22 microfarad cap here, 100 microfarad power input filter cap, and then these two big 4700 microfarad caps. Does that improve the sound? Not really. The sound on Whitewater and FishTales was not great to start with, but it does make it one of the quietest sounding soundboards you'll ever hear. On power up, you can barely hear the thing ticking like they typically do. Oh, it also blew up, or it had a 1 microfarad tantalum cap that was blown up right here. It's fairly typical. These three, there's one here, there's two back here. Sometimes they just blow up. Old age, subjected to reverse current. There are a number of reasons they can blow up. They just do. Never causes any damage to the board. Just replace them and press on, and you can replace them with an electrolytic cap. So that's it. Board set's good to go. Let me go get that Fliptronics board out and fix it too.